By the end of this lesson, I will be able to find angle and arc measures, use circumscribed angles. When a chord intersects a tangent line or another chord, what relationships exist among the angles and arcs formed? The tangent and intersected chord theorem. If a tangent and a chord intersects at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Notice that the measure of angle 1 is equal to half the measure of its intercepted arc. The measure of angle 2 is also equal to half the measure of its intercepted arc, which is arc BCA, a major arc. The measure of angle EFH will equal half the measure of its intercepted arc, which is 130. Half of 130 is 65 degrees. The measure angle G will equal half the measure of its intercepted arc, GF. We'll also need to use the fact that these two angles form a linear pair. So therefore, the measure angle G is equal to 180 minus 22 degrees. Let's simplify that. So we get 58 degrees. And to solve this, we will have to multiply both sides by 2 to get rid of this fraction. And that leaves us with the measure of arc GF is equal to 116 degrees. Intersecting lines and circles. If two non-parallel lines intersect a circle, there are 3 places where the lines can intersect: on the circle, inside the circle, or outside the circle. The angles inside the circle theorem. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. The measure of angle 1 will equal the average of these two arcs. All right, so its intercepted arc and the intercepted arc of its vertical angle. Or we can say the measure angle 2 is equal to the average of these two arcs. So therefore, its intercepted arc and the intercepted arc of its vertical angle. The measure angle ABD will be the average of its intercepted arc and the intercepted arc of its vertical angle. Substitute the values in, add, and half of 102 is 51 degrees. In the next problem, we want to find the measure of angle RNN, which we are not given any information for its intercepted arc, its vertical angle, or the intercepted arc of its vertical angle. But we are given the measure of the intercepted arc of angle MNQ and the measure of the intercepted arc of its vertical angles. So we'll start with that. Let's substitute the values in, and we get 158 for the measure of angle N and Q. Notice that these two angles form a linear pair. So therefore, the measure of angle R and N will be the supplement of 158. So when we substitute the values, we get 22 degrees. Inscribed angle of a circle theorem. If a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Again, this is a tangent, this is a secant. These are two tangents, these are two secants. All right, and remember, a tangent will intersect the circle at 1 point, while a secant will intersect the circle at 2 points. Find the value of x, or the measure angle DEF is equal to half the difference of the two intercepted arcs. So in this particular case, substitute our values in and simplify, we get 40 degrees. Two of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. If the measure of arc AEB is 225 degrees, what is the measure of angle ACB? The measure of angle ACB will equal half the difference of its two intercepted arcs. Let's substitute the values in and simplify. 45 degrees. If you are wondering where the 135 came from, remember the measure of a circle is 360 degrees. If this arc that goes AEB is 225 degrees, the remaining arc is the remaining portion of 360. 360 minus 225 is 135. That's where 135 came from. By giving you a complete circle of 360 degrees. Circumscribed angle theorem. The measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. Therefore, the measure of angle ADB is equal to 180 minus the measure of the central angle ACB. Find the value of x. The measure of angle QSP will equal to 180 minus the measure of the central angle that it intercepts, QRP. Substitute the values in, subtract, and x is equal to 56 degrees. First, remember that angle ACB, which is an inscribed angle, is equal to half the measure of its intercepted arc. We also know that the measure of the central angle AOB is equal to the measure of its intercepted arc. Therefore, if the measure angle ACB is half the measure of the intercepted arc, it's also half the measure of the central angle. Next, we can use the circumscribed angle theorem to state that the measure angle ACB is equal to 1/2 180 degrees minus the measure angle ADB. Why can I say this? Let's go back to the circumscribed angle theorem. When we look at the circumscribed angle theorem, it says that the measure angle ADB is equal to 180 degrees minus the measure of angle ACB. We can use a symmetric property. We can subtract 180 degrees from both sides and then divide through by -1. Now it states that the measure of the central angle ACB is equal to 180 minus the measure angle ADB, which means that these two angles are supplementary. That's what it says. So anytime we have this statement, it's just stating that the two angles are actually supplementary. Let's take a closer look at that. Supplementary angles are two angles that have a sum of 180. If this angle measures 30 degrees, the supplement will be 150 degrees. How do we get 150? By going 180 minus 30, which is 150. I could also go 180 minus 50 to get 30. Therefore, since we know we have a quadrilateral here, since we have 4 vertices or 4 sides, we know that the measure angle A plus a measure angle B plus a measure angle C plus a measure angle D is equal to 360. We know that the measure angle A and B are 90 degrees. Since we know that ray DA and DB are tangent rays, simplify, subtract 180 from both sides, and we have the measure angle C plus the measure angle D equals 180, which by definition means they're supplementary. Find the supplement of 20 degrees, we would just say 180 minus 20, which is 160. If we want to know, find the supplement of 45 degrees, we would go 180 minus 45 is 135. Another way of looking at that shape is that the shape is actually a kite. The measure angle AOB, we can substitute 180 degrees minus the measure angle ADB, since these two angles are supplementary, angle ADB and angle AOB. Substitute our values that we know, simplify, and simplify some more.